Okay, so we're just going to take a brief break here from the coding and stuff just to kind of teach you guys some basic foundational coding concepts that you guys can, or probably will recognize from actually building your programs. We want to give you guys some formal knowledge that you guys can take and move forward with as you hopefully pursue education and career in computer science. So first we have Brian, who I believe will be talking about
loops.
Loops! Cool loops. So Brian, if you would like to take the floor.
Alright, I'll go around.
Yeah. And be careful of all the cords up here. It's pretty messy.
Thank you very much.
No problem at all.
Before I sort of jump in, I was going to show like a couple of quick examples, but do you all have kind of an idea of what a loop is? Does anybody have an idea of what a loop is? No pressure. If not, that's totally cool. No? Alright. Well, the short version of a loop is whenever you have something in your program that you want to happen kind of repeatedly. So in a game, for example, you might want to have a game loop, right? So while the game is going on, you might want to ask your player a question. And if the player doesn't answer that question correctly, then you might want to sort of loop back over and ask them that question again. That's sort of what you might have experienced with your game. Another very frequent or common case of a loop, though, is if you need to basically have something happen more than once. So one way to do that is you could literally write out the code over and over and over again. So I'm gonna do some real quick live coding. So for example, if I wanted to, I don't know if you can see that very clearly, but if I wanted to do something like, this is sort of a really silly example. But if I wanted to print something multiple times, there's the obvious way of just writing that code over and over again, right? But after a while, that would get old. Like, imagine, a silly example, but if you had to print something 50 times, right? You wouldn't really want to write print 50 times, right? Or print 1 through 50. So the other way to do that, particularly in Python, is there's a for loop, right? And so a for loop says if you want to do from a starting point, so like 1, and you want to go all the way to 50, then you can use a for loop to basically iterate, which is sort of a fancy programming word to sort of do something over and over. And so you can say for, in this case, in Python you can do range. Range is another specific term in Python. And then you can you'll notice how it does a little bit of indenting. You've probably seen the indenting in your code. So anything that's indented is inside that loop, inside that for loop. So anything inside or indented is going to be executed that number of times. And so in this case, just like that, I was able to have something print 50 times. It's kind of hard to see here. Another advantage of for loop, so imagine if I wanted to change the print to do something else. So if I had this statement literally printed out 50 times, I would have to go in every single line, I would have to change what happens on that line. But in this case, so imagine I wanted to print rather than 1 to 50 if I wanted to do multiples of 2. And these are sort of contrived examples, but hopefully you can see how they apply. The nice thing here is if I wanted to say multiples of 2, there's literally one line that I have to change. And all of a sudden my entire program does what I want it to do. As opposed to the other case, I would have to go and find 50 lines and I would have to change them in every single case. So that's kind of a real quick overview of loops. Another example that you might see in your program is, I know in our program we had choices. So the user, for example, you would give the player choices like, choose 1 for this, choose 2 for that, choose 3 for this kind of thing. So in Python you can do a list. So in this case we'll say choices, and we'll say press 1 for something. What the something is, I'll leave up to you as sort of in your game. You can say press 2, press 3, right? And so now we could actually say for choice in choices. So similar sort of syntax like we saw with the numbers. You say for variable and then in, which is a list of things. And so in this case I can say for choice, and then if I say print choice, it'll actually print out each of those options. then you can say, let's see, picked equals input. Hopefully some of this is a little bit familiar from your game. You can say, enter your number, for example, right? And if I rerun that, it'll say enter a number. And now all of a sudden I can say, well, if picked equals 1, do something, else if picked equals 2, do something. Does this sort of seem familiar from your game? You sort of saw some of these, if the red door, if the blue door, that kind of thing. And so the nice thing about this is I can say live coding, typing on the fly. So lost my choice here. So if I rerun that, now I can press binder 2, greater live coding. So I don't know, forget the example for a moment, but you get the idea that now you can actually easily create choices. So if, for example, all of a sudden I wanted to say, I really want to give my players a choice 4, all I have to do in this case is add a choice up here in my list, and then all of a sudden I give the player a new choice. I still have to program the logic down here that says if picked equals 1, if picked equals 2, if picked equals 3. But the nice thing is, if I create this list, I can very easily add to that list, and all of a sudden I give my player new choices. So hopefully that gives you some idea of how this is a list of things that you can then loop over and give your player or your game all of a sudden certain new choices. So hopefully that was helpful. Any questions? Awesome.
Everyone got
Thank
it.
you.
Good. Sweet.
All right. Thank you very much. Adam, thanks. All right. Hey, live coding.
Yeah, yay for live coding. Well, I'm not going to code. I'm not going to say this for this too.
If you don't need that, I don't need it either.
Now let's sort shut this down.
Yeah.
Where's the button? I'm technology
Shut
division.
it down.
The system is down.
It's done.
Yes.
It's dead.
All right. Well, I have for you a scientifically accurately proven fact. Oh yes. You have no idea where I'm going with this, do you?
No clue.
Well, here's the fact that is absolutely proven scientifically and empirically, and that is that ninjas hate pirates and pirates hate ninjas. Oh, I mean, am I right?
That's
Am I
fair.
right?
That's fair.
Well, it's a scientifically proven fact. Of course it's right. So here's the deal. I'm a programmer, and I've got users, and users are the one who's telling me, hey, Adam, I want you to write me a program, and we've got a problem. We need to know whether we're going to be making an awesome pirate ship or a dojo for our ninjas. We will have money to make one of these things. So what we're going to do is we want you, Adam, to write a program to tell us which one we should build for our people to take over the world. So that's where I come in. You know what? I'm going to write a program that tells them how to do this. And I go, well, you know what? No big deal. I know how to do conditionals. You saw him do a second ago. Conditionals are the most important part for telling them what they need to know. So what we're going to do, you're going to help me out. I know we're kind of late in the day, but it's going to be a quick little exercise here. So what I need to know from you guys is if you like pirates better than ninjas, I need you to raise your hook in the air and go, yar! Any pirates better than ninjas?
Hey.
Hey, we got one. Yay. So if we like the ninja better, do we raise our sword in the air? I see. 1, 2, 3. Yes. Oh, we have a very strong ninja army. Yes. So.
Take you guys.
Indeed. So, one way or the other. Now, what we have to do is we have to write a program that says, well, what do we do with this? How do we actually determine whether or not to make one either the dojo or the pirate ship? So what we do is we write a condition. We say if the number of pirates are greater than the number of ninjas, then we make the pirate ship. If it's the other way around, we make the dojo. So based upon this, what I do is I go to my program and I write out that statement. If one is greater than the other, I know what to do. So now here's the question. Based upon the data we have here, are we going to be making a dojo or are we going to be making a pirate ship? Dojo's happy. So that's what we're going to do. So I go to my users and I say, hey, here's my program, push the button and go. And it tells them that they're gonna be making a dojo. And that's exactly what they do. They build a dojo, all the ninjas have a great time, they beat each other up and save the world. So there you go. Conditions are all about taking values, evaluating them, and figuring out what to do based upon those values. So there you go. Short and sweet. Huzzah!
Huzzah! Wonderful. So I'm last, and I'm also going to try and keep it short and sweet because I hate lectures. So I'm going to talk about methods. I'm almost positive you guys have encountered this while learning to program in Python and building your code and all that kind of stuff. But I'm just going to talk about 3 things that I think are most important when thinking about methods, and maybe quiz you guys a little bit on how much you understand methods already. So the first thing to think about with methods is the idea that it's basically reusable functionality. Like that is the purpose of a function. It's code that you've either used more than once and you realize I might as well just call this code, this one thing that represents this functionality over and over rather than rewriting that one chunk of code over and over again, which is part of the reason why it's sometimes called subprograms. Based on the input and output, could run by itself. Probably isn't going to do much, but it's going to do something. Another thing is that methods can take in values and they can return values. They can be objects, they can be numbers, they can be strings. So we have 2 functions here, function 1 and function 2. Can anyone tell me which function is taking in values? Just from looking at it? Function 2? What about function 2 tells you it's taking in values?
In a second. I mean, because it has the P1 and P2 in the front.
P1 and P2? Cool. So those are called parameters. And so anytime you want to pass something into a function, whenever you define the function, which is what this is, def func2, parameter 1, parameter 2, you want to make sure that those are getting passed in here. So then that kind of makes it obvious, but what is the other function doing? It's returning a value, right? So if a function isn't accepting values, it's possibly returning values. So here we have a function that literally just returns 1. So when we call this function, it's going to return the value 1, right? So the idea, functions can take in values, they can return values, they can do both at the same time. So really func2 could take in P1 and P2, do something to P2, and then return it back. So there are a lot of things you can do with functions. One of the nice things, though, is it makes your code a lot more readable. It's easier to access pieces of your code, again, that you use over and over again. And it helps for other people that are working with you to know what exactly you're trying to do with your code and what pieces of functionality you have. And finally, one of the more important things, which I think I remember, I don't know about you guys, but I remember people running into this issue, but the methods that you implement are attached to the file or class that they're implemented in. So does anyone have any idea, if I wrote a class or a file and put some methods in it, and then I went to a whole other class and wanted to use that method, how would I be able to use the method in the other class? Does anyone know? I know you guys ran into it. When you were using the turtle stuff, what was the first thing you had to do to be able to make Tina the turtle? Do you guys remember?
You have to put that in there.
Put, like, bring turtle into it, right?
Yeah.
Do you remember what that was? I'll give you a hint. It starts with an I.
Hold on.
You know it. I know you know it.
No.
Close.
Oh my gosh.
Exports and
Import.
import. Import statements. So, I crossed it out. But import. So, anytime you want to use a method that is not in the class you are currently working in or the file you're currently working in, import whatever the name of that file is, and you have access to those methods. Questions? Yay. Method. That quick. Boom. Lightning talk. Like that.